All right, now let's get to some real tough equations, or at least equations that look like they're super tough, but turn out to just be wearing a big messy disguise. So we're going to talk about solving equations that have lots of fractions in them. And people always freak out when they see them because they think, I don't know what to do with them. But you know what? They're not so bad if you know the secret trick. So here we go. Here's the big idea. Is that any time you have an equation that has a lot of fractions in it, you can turn it into an equation that doesn't have any fractions in it and looks like the ones you already know how to do. And the big idea is you need to multiply all terms by the least common denominator of all of the fractions. After you do that multiplication, you should end up with an equivalent equation, which means the solutions are the same as what you started with, but you won't have to deal with any fractions. So here we go. 3/5 x plus 1 equals 2/3 x minus 2/15. Most people look at that and think, what a mess, I just want to run away. But again, you're going to know the secret, so you're going to know how to solve this. Again, the big idea was to look at all of the denominators. So in this case, I'm looking at this denominator, and this denominator. And if you really want to be technical, this number right here has a denominator of 1 also. So the least common denominator for 5, 1, 3, and 15 is 15. So what I'm going to do is multiply everything by 15. And if you want, you can write it 15 over 1 on both sides. And then typically what I do when I'm first starting out with these is I write this next to each term. So 15 over 1 times 3/5 x plus 15 over 1 times 1 equals 15 over 1 times 2/3 x minus 15 over 1 times 2/15. Now that's probably the messiest part of the whole problem, because watch the magic unfold. I chose that 15 because these denominators divide into it. So 5 divides into 15 3 times. 3 divides into 15 5 times. I'm getting little ones down here. And 15 divides into 15 1 time. So now when I write down what I have left, after I do that multiplication, these denominators are all 1, so I just have 9x. And that 9 comes from this 3 here and this 3 here. This one, nothing canceled, so I just have 15 times 1, which is 15. On the right side, denominators are 1, so I have 5 times 2x, that's 10x. And then here I have 1 times 2, which is 2. So I started with this really ugly equation, did one multiplication that involved multiplying fractions, and I end up with an equation that has all integers or whole numbers in it. So at this point I can just solve my equation the way I've solved equations before. In this case I'm going to get my x's on the right hand side. You could get them on the left hand side if you wanted to. And then I'm going to add 2 and I get x equals 17. So the hard part is really getting from the original equation down to this line right here where you end up with no fractions. Then it's just like things you've done before. Let's try another one. I'm going to look at all of my denominators that I have that are scaring me. Not really, because I know the secret. 8, 4, and 2, and the least common denominator of those is 8. So I'm going to multiply everything on the left by 8 over 1 and everything on the right by 8 over 1. And I'm going to carefully write this out. 8 over 1 times 3/8 x, 8 over 1 times 1/4, 8 over 1 times 3/2 x, and 8 over 1 times 1/2. Now when I do this multiplication for each and every one of these, I should end up with no more fractions. 8 divides into 8 one time. 1 times 3 is 3. This is just 3x. 4 divides into 8 2 times. 2 times 1 is 2. Next one. 2 divides into 8 4 times. 4 times 3 is 12. And I've got an x there. Last one. 2 divides into 8 4 times. 4 times 1 is 4. And then again, now you've got no fractions left. You solve it like you solve other linear equations, moving your variables to one side, your constant terms to the other. Oops, I'm going too fast. I need to subtract 4 from the right side. So I get 9x equals negative 6. And then I need to divide by 9. Now in this particular case, I get negative 6 over 9, which as a fraction reduces to negative 2/3. Now don't be scared if you get a fractional solution when you have this many fractions to start with. That's really not uncommon. Okay, and now just reviewing the two methods we've talked about. We've talked about a reciprocal method, and we've talked about multiplying by a common denominator. And I just want to review those and show you that you get the same thing. So the first method we talked about when we just had one coefficient of x that was a fraction involved using the reciprocal. So one way we did this problem, 3/5 x equals negative 1/2, was to multiply by the reciprocal, which is 5/3. These all cancel. I get negative 5/6. Now, I just wanted to show you that we could also use the method we were just talking about, which is to look at the common denominator. In this case, I've got a 5 and a 2. So the common denominator there is 10. So if I wanted to, and I didn't want to worry about a reciprocal, I could use the same method. Multiply by 10. When I do that, 5 divides into 10 2 times, so I get 6x on this side. 2 divides into 10 5 times. Negative 1 times 5 is negative 5. And then I divide by 6, and I get the exact same solution that I did when I used a reciprocal. So you can use either method in these last couple of examples. And the last one here, in the first video about fractions, the way I solved this problem was I added 5 to both sides. I got 2/3 x equals 4. And then because this was the only fraction, I multiplied by the reciprocal, which was 3/2. These all cancel. I get 1x. And on the right side, I get 6. That's how I did it in the first video. Using the technique that we just learned in this video, I can multiply by a common denominator, and I only have one denominator here, which is 3, but I can still do it this way. If I want to multiply everything by 3 at the very beginning and get rid of my fractions right away, I can do that as long as I do it on both sides. So I have 3 over 1 times 2/3 x minus 3 over 1 times 5 equals negative 1 times 3 over 1. This becomes 2x. Second term becomes 15. The right side becomes negative 3. Now if I solve this, I get 2x equals 12, divide by 2, I get x equals 6. Exact same solution. So I think the reciprocal method is faster, but I just wanted to show you that if you really want to use this method of getting rid of your fractions by multiplying by the common denominator, you can always use it. That's the end of the video on fractions. We're no longer afraid.